Today on 20th March 21, we are here to continue with subject physics. Up till now, we discussed the contents from unit electricity. Electricity is studied under two branches separately. One is static electricity and the other is current electricity. Static electricity deals with behavior of charges at rest. The charges at rest produces their own electric field. In current electricity, we study the effects produced by charges in motion. So charges are there. So there is electric field associated with, and due to their motion, they produce few more effects. So the current flowing through conductor gives you more effects that we continued. So the study never stops. So when you deal with charges in motion, such charges in motion produces different effect. One of the most peculiar effects of charges in motion is magnetic effect of electric current. Along with electric field associated with charges, charges in motion are able to produce magnetic field also. This effect is first given or found by scientist Oersted in 1820. So I am going in fundamentals. So in 1820, the scientist Oersted discovered the effect magnetic field produced by electric current. Also, when the study is still further continued, in year 1831, the another scientist Faraday proved if the conductor is kept in varying magnetic field in the region should vary with respect to time. He proved if this is the case, you get production of electric current, or electric current is induced in the conductor using the conclusion drawn by Oersted and scientist Faraday. The further in 1864, the scientist Maxwell proposed there should be certain linking between electric field and magnetic field, because Oersted proved the magnetic effect of electric current. Faraday proved the induced EMF if magnetic field is varying, time varying. Combining these two, in 1864, the scientist Maxwell, who is the founder of EM waves, proposed that there should be certain relation between electric field and magnetic field, and Maxwell is thus called, or is said to be, the founder of EM waves. So Maxwell proposed in 1864 these EM waves exist and is called Then, based on his proposal in 1888, the scientist Hertz tried experimentally to prepare EM waves. He performed the experiments to demonstrate existence of EM waves. He was able to produce EM waves experimentally of the wavelength 5 meter. Immediately after 6-7 years after the Hertz, the Indian scientist Jagdish Chandra Bose in 1895 produced EM waves of wavelength ranging from 25 millimeter up to 5 millimeter. Hertz was meter. Hertz wavelength was in meters. Jagdish Chandra Bose, who is the Indian scientist, produced EM waves of wavelengths ranging between 25 to 5 millimeter. Then followed by him in year 1896 up to 1899. This is the range of the years. The scientist Marconi brought the milestone in EM waves. He produced EM waves and he gave the method to transmit them over the large distance. He is the founder of telecommunication. Nowadays, in modern life, for all telecommunication purposes, these EM waves are used. So today we are starting the chapter number 13 on page 229. So I have began chapter 13. EM waves and communication, which starts on page 229. But that EM waves have history since 1820, when the study of unit electricity was there, continued. In 1820, the scientist Oersted proved magnetic effect produced by charges in motion, that is current electricity. Faraday proved if the conductor not carrying current initially is placed in varying magnetic field, automatically the current gets developed. So current produces magnetic field, proved by Oersted. Varying magnetic field induces the current, proved by scientist Faraday. And this combination of these two conclusions, Maxwell interpreted there should be certain linking between electric field and magnetic field. He proposed the existence of EM waves and put up the theory that EM waves should be there, should exist. The work on this principle proposed by Maxwell is performed by scientist Hertz, and he first experimentally demonstrated in 1864 the production of EM waves. Followed by him in 1888, the Indian scientist Jagdish Chandra Bose demonstrated and produced experimentally EM waves of wavelengths in the region 25 millimeter to 5 millimeter. He was able to propagate them up to certain distance, not much more. Then in 1896 to 99, the scientist Marconi produced EM waves of covering range of wavelengths, and he also developed their propagation, their transmission, which is the milestone in now telecommunication. So this is the background behind this modern physics. All these part lie in modern physics. So today we will start with chapter 13, electromagnetic waves and communication system, on page 229. So what happens? Marconi started studying much more on EM waves. He's proved that these EM waves are generated by accelerated charges. When we consider motion of charges, if motion is steady across this conductor, we get a steady current. And steady current produces magnetic field in its surrounding of the conductor. The magnetic field produced also is steady, does not change in magnitude, not in direction, because steady current flows. But Marconi what suggested, if this steady current is varied, change with respect to time, you should either change its magnitude or you should change its direction. This can be only done by using oscillatory charges. Oscillatory charges execute oscillatory motion, to and fro motion along the same path about a particular mean position. So if these charges moving are made oscillatory, so that they will be accelerated. Acceleration is produced when velocity changes. So if charges are oscillatory, their motion is accelerated, and accelerated motion changes the magnitude as well as direction with respect to time. So he, as you proposed, these oscillatory charges perform acceleratory motion, and acceleratory motion of charges produce time varying magnetic field. This is magnetic field which is steady. If the motion is made oscillatory, then magnetic field produced at a given point changes with respect to time. That is called time varying. So time varying magnetic field produced in turns generate time varying electric field. At the same point, time varying electric field in turns regenerates time varying magnetic field. These two fields produce each other, regenerate each other, and the fields produced do not get confined at one given point. Instead, they start propagating in the surrounding medium. So this is the disturbance, oscillatory disturbance, in which time varying electric field and magnetic field are carried along. This magnetic field developed is perpendicular to the motion of charges, and in turn magnetic field develops electric field which is still perpendicular to this magnetic field. So these two fields are mutual perpendicular to each other. The second property, the Marconi proved, these two fields are always in phase. That is, maximum value and minimum value of these two fields are at the same instant, occur at the same instance, and they are said to be in phase. One more quantity he proved, these two fields generated have same frequency. Both fields have same frequency, and the frequency is equal to frequency of oscillatory motion of the charges. So these two are time varying, in phase, having same frequency, regenerating each other, mutually perpendicular to each other, and once they get generated, they do not get confined to one particular point. They start propagating in the given medium. They start moving away from the source, and we get production of EM wave. So the question can be said, define EM wave. You can write, it is oscillatory disturbance in which electric and magnetic field vibrating sinusoidally, time varying, is given by sine wave at right angles to each other, in phase with each other, and mutually perpendicular to each other. It is proved further they are perpendicular to direction of propagation of EM wave. So we can define it. How are they produced? They cannot be produced by steady motion. The motion should be oscillatory, and hence we can show them pictorially. The three directions. And this is the third. If this is z axis, if this is x axis, then this will be, you can show the other way. This is y axis. So let the wave propagates in z axis, along z axis. Let the charge oscillates along x axis. So magnetic field will be perpendicular, will be generated along y. Electric field will be perpendicular to y, that is along x. So if the wave propagates along z, let field electric is developed along x. It is time varying. So electric field has electric field vector. At the same time, magnetic field should be generated along this y. So these two are perpendicular to each other, and both propagate perpendicular to direction of propagation of wave. So this is magnetic field and this is electric field. So you can show diagrammatically the presentation of EM wave along z axis. So this is the production and propagation of EM wave. I have moved to page number 230. On page 230, the diagram is given 13.1. See the diagram, open the books and see the diagram. It is 13.1. Along z, the direction of propagation, along x, the electric field vector, and along y, you are getting magnetic field vector. Both are in phase, means maximum value of E and maximum value of M occur at the same instant. When magnetic field has minimum value, electric field should also have minimum value. So this is in phase. Their frequency of oscillation is same. So these are few common properties of electromagnetic waves. So now we will switch over to study more few characteristics of EM waves, which is point number 13.2.2 on page to 30. So they have listed a few properties of EM waves. EM waves, first property, they are produced by accelerated charges. The motion should be accelerated, oscillating. The second property, electric magnetic field always perpendicular to each other, in phase, have same frequency and always perpendicular to direction of propagation of wave. Then third, E and B bar, the cross product gives you direction of propagation of wave, which is represented by K bar. K is called propagation constant. Then we will switch over to point 4. E and B already in phase. When they are generated, they can propagate through material medium as well as through vacuum. This is the next property. They do not require material medium. They can propagate through vacuum also. Means through material medium they pass, but through vacuum also they are able to pass. When they propagate through vacuum, their velocities is equal to velocity of light, given by formula 1 upon square root epsilon naught mu naught. Epsilon is permittivity, is a constant, permittivity of free space, and mu e naught is permeability. It is the another constant of free space. When travel through any other medium, I have switched over to property number 7. Their velocity gets affected, and velocity in any material medium is 1 upon square root epsilon mu, where epsilon is permittivity of that particular medium and mu is permeability of that particular medium. These two values are always greater than the corresponding values of air or free space. So velocity reduces when EM waves travel through material medium. They have maximum velocity when pass through free space equal to velocity of light. If you substitute these values, the last answer you get 3×10⁸ meter per second. So when they propagate with this, the ratio of amplitudes of two fields not equal. The value of magnetic field associated is very weak in comparison with value of intensity of electric field. So V is weaker. Its value is Ce upon C. So ratio of amplitudes of electric and magnetic fields at every instant is B is equal to E upon C. Electric field is thus more prominent. The electric field and magnetic field are represented with sine wave because they are sinusoidal, time varying. Even both are in phase, we can represent it with the help of sine wave, omega t minus kx, assuming the wave is propagating along x direction. Similarly, the magnetic field we can represent with equation where E naught, B naught are amplitudes of electric field and magnetic field respectively. K is called propagation constant and its value is always 2 pi upon lambda, where lambda is wavelength of generated electromagnetic wave. Omega is called angular frequency and it is equal to 2 pi mu. So these are few properties. The intensity is proportional to amplitude. So intensity of electric field can be expressed in terms of E naught, and intensity is always proportional to square of amplitude. You can express intensity of magnetic field associated in terms of square of B naught, amplitude of magnetic field. And the formulae to express IE and IB are given on page 231, equations 13.2. Since electric field is more prominent, IB at given instant is less than IE at the same instant. So these are the properties of electromagnetic waves. After discovery of electromagnetic waves, many experiments were performed in which we observed production of EM waves over the wide range of frequencies. Means EM waves of different frequencies can be artificially created, can be artificially generated. So EM waves cover a wide range of frequencies. Orderly distribution of EM waves according to frequency or arrangement of EM waves according to their frequencies either should increase or should decrease covers this range, and the range covered is called EM spectrum. So on Monday, we will continue to study what is EM spectrum, what is its use, what are different distinct regions in EM spectrum with their properties and uses. Today, since time up, we conclude the lecture only by studying how are EM waves generated, what is EM wave, and what are the characteristics of EM waves by knowing basic the history about their proposal. So thanking you all. I am stopping here. You have to join the next class for other subject. So thanking you. I am closing the Zoom meet for all. We'll continue with EM spectrum on Monday.